Viscon's base component is a high molecular weight, non-toxic, pure hydrocarbon polymer. It is blended directly with fuel and used in a wide variety of applications to improve engine performance and reduce harmful emissions. The uniqueness of Viscon is its ability to improve the quality of air and fuel mixture. As a result, the fuel becomes highly viscous when injected into the cylinder of a diesel engine. It does this by changing the physical behavior of diesel fuel, in contrast to changes in chemistry common to all other fuel technologies. Adding Viscon causes a more uniform fuel droplet formation, greater kinetic energy of the fuel spray, and a more uniform vaporization of the fuel species. Let's take a look at what happens in a combustion chamber without and with Viscon added to the fuel. It is a property of all liquid sprays to have a range of droplet sizes in a spray pattern. This non-homogeneous behavior is increased when diesel fuel is injected into the high pressure gas in the cylinder. Droplets grow in size as the leading edge of the spray encounters high pressure, and follow-on droplets collide and coalesce. Another property of a liquid spray is that as it breaks down into droplets, it loses forward momentum. This loss of momentum is particularly significant when diesel fuel is sprayed into high-pressure gas in a cylinder. The injected fuel also contains a mass of superfine droplets that combust in a cloud rather than burn diffusively from a droplet's surface. During the vaporization process, traditional diesel droplets first vaporize the light ends from the body of a fuel droplet, leaving behind a core of the heavier, slower burning species. As a result, the unburned or partially burned droplets cause the exhaust heavy in particulate matter and harmful gases. The addition of Viscon to diesel fuel changes spray development. Superfine droplets do not form in the spray pattern, and large droplets formed by collision are reduced. The overall average droplet size diameter is smaller, and the spray cone is more uniform in droplet size. Also, the viscoelastic droplets are resistant to breakup in the spray pattern, giving them greater momentum to penetrate the high pressure gas in the chamber. During the combustion, both the light and heavy species vaporize from the surface of the fuel droplet. The result is a more uniform blend of light and heavy species prior to combustion. As the superfine droplets are virtually eliminated from a liquid spray, the heat release rate is also reduced. All of this contributes to the Viscon blended fuel achieving a more complete burn, which greatly reduces emissions of the particulate matter and greenhouse gases. Let's review the combustion process side by side. When injected into the compression chamber, the traditional diesel fuel has a range of droplet sizes in the spray pattern. They vary from superfine, vapor-like, to large, collision-caused droplets. Viscon treated fuel, on the other hand, has an overall reduced size of the droplets and virtually no superfine droplets. Raw fuel injected into the cylinder auto-ignites before fuel and air mix. Immediately following ignition, there is an excessive rate of heat released, which contributes directly to the creation of nitrous oxide. This is caused in part by a mass of superfine droplets in the fuel jet, which ignite explosively like a vapor cloud. By reducing the growth of large droplets and making the fuel vapor a more uniform blend, Viscon makes the fuel combust more evenly and burn cleanly. Viscon has been officially verified to drastically decrease airborne pollutants caused by harmful engine exhaust emissions in a cost-effective way.